This is example 14. It says A, B, C, D, and P are different real numbers. They are real numbers having different values. Further relation is given between A, B, C, D, and P, and it's being mentioned that it is less than equal to 0. It means it is either 0 or less than 0. And we have to show that, we need to show that A, B, C, D are in GP. That means what in all we have to prove is, that is to prove is B over A is equal to C over B is equal to D over C. That's what we have to prove. So what we can do, we can start from here. We will open this bracket, right, and see what we are getting, a relation between A, B, C, D. So it can be on applying distributive property, it will be A square, B square plus B square, B square plus C square, B square minus 2AB minus 2BC minus, oh, there's a P also, this P, minus 2CDP plus C square B square plus D square is less than equal to 0. Right, what we can see here that there are identities that can be framed using these. So you can see that this, and this can be clubbed together to form an identity. Let me write down A square P square minus 2AB P and plus B square. Similarly, I'm clubbing this B square P square minus 2B CP plus C square, and finally the last one, that is C square P square minus 2 CDP plus D square, right? That is less than equal to 0. So what do we get here? That this turns out to be AP minus B whole square. The next, it turns out to be B P minus C whole square. And the last one, it turns out to be CP minus D whole square, right? And this is given, it is less than equal to 0. But you should know that square of a number is never negative, right? I mean, square of a number is always positive. So if you are adding 3 positive number, you should get always a positive number. And or they can be they cannot be negative, right? So the square of a number is always positive. So sum of positive number, square of a number is always either positive or 0, right? Square of a number can never be negative. By that I mean to say, it means that some of these numbers cannot be a negative number. So they each must be 0, right? Once again, if I add 3 numbers, square numbers, they will never give you a negative number. It implies that there has to be 0, like each of them, this, because sum of 3 zeros can give you 0. So that is what the concluding point. So we are going to equate each of them with zeros. So on equating with zeros, what we get? In the first part, if I equate this part with 0, we'll get P as B over A, right? And if I equate this with 0, what I'll get? This will get P as C over B. And finally, if we equate this with 0, we're getting P as D over C. Now, as you can see, all of them is equal to P. Therefore, our final conclusion will be that since this, and this, from these 3, we can say that B by A is equal to C by B is equal to D by C. And this is what we had to prove, well, which is equal to P. So we can say that it's in GP, they are in GP, A, B, C, D are in GP with common ratio, right? We got the common ratio, and the common ratio is P, right? P is the common ratio. This is how this question can be solved.